Hey, good afternoon, you guys. It's a pleasure to have you on. I really appreciate it. You know, we obviously love the Theia satellite project. We have Erlend Olson, the COO of the entire effort here, and we also have Dr. Joseph Pelton, who's going to interview Erlend. He's on the executive board of the International Association for the Advancement of Space Safety. Joe, your resume is too voluminous to read the whole thing, but suffice it to say it's very impressive. And you're the founder of the Society of Satellite Professionals, the Arthur C. Clarke Foundation, and played a key role in the founding of the International Space University. You announced the formation of the Clarke Foundation at the White House in 1983. That must have been your father who did that, not you. Well, you were acting managing director of the National Committee for World Communications Year, a U.S. presidential appointment. So thank you very much for you guys for coming on. Really appreciate it, and looking forward to the play-by-play. Thank you so much.
It's great to have this chance to interview Erlend. His co-founder was a student of mine at George Washington University, so I followed this project with great interest. So let's start off with the vision. This is really a unique system with unique capabilities. And what is it that you and Joe were trying to do?
So Joe and I both come from remote sensing backgrounds, and we had a lot of experience using remote sensing equipment on aircraft to do various things to support physical industries. And basically the business was building a measure, analyze, adjust feedback loop, measure something, analyze it, and then give feedback to the physical business or the physical industry to help it achieve a more optimal outcome. The problem with doing that from aircraft is there's an enormous logistical challenge. You got to fly airplanes around, you got to collect data, you have to have permits, and you burn a bunch of fuel. It doesn't scale well. You can make a lot of money one day and make no money the next day. So from a business perspective, we thought about how could we scale this, sort of keep costs constant and scale it so it become a global business. And that's what led us to satellites, right? So the key was, could we put the sensors in space that would produce the same resolution, same quality that we needed for all these algorithms we had developed from using data from aircraft that were flying relatively close to ground. And, you know, circa 2015, about 5 years ago, Joe and I started thinking about this problem deeply, and we realized it was possible to do. And that's when we set out to build the satellite network. You know, our team was unique in having both remote sensing expertise on the algorithm side. So we developed these algorithms. We knew they worked. We knew how to make money in some of the various physical industries using this kind of a technique, but setting out to scale it was a whole different endeavor. So that's when we started the Theia Satellite Network as a business called the Theia Group Incorporated, and set about to come up with a system that could essentially digitize the whole world, or digitize things at a scale and simultaneous granularity that we needed to make these algorithms work. So, you know, once you have some algorithms that do this measure, analyze, or measure, model, modify feedback loop, the algorithms don't care where the data came from. It came from an aircraft, came from satellite. Just as long as you have sufficient resolution and quality, that's the key element.
Now we have a feeling for the vision. Let's talk about how all these things work. You know, there are a lot of these constellations going up. Elon Musk is putting up maybe 12,000 of these really small satellites, but you're doing something different. You are putting up only 112 sensing satellites, but with incredible capabilities on them, which in my view is a more responsible way, and I think maybe a more successful way to go. But tell me about what these satellites will do and how the whole thing works together. How do you process the information once you've got the data?
Well, first I'll differentiate between some of the other more popular and well-read constellations and us. Those constellations like the OneWeb and Starlink are or for communications, and that's a great business, and God bless them. We're in the remote sensing business, which is different. We have communications capabilities, but for the support of the remote sensing based business. Our system is designed to essentially digitize the whole world continuously, which I'll describe further in a minute, and do that at a rate that is faster than the underlying activity rate of most of the physical industries that we support and have algorithms for. And the configuration, I'll make this sound a lot simpler than it really is, but the configuration of our constellation, our initial deployment, is 112 satellites deployed in 8 planes. So these are orbiting around the Earth, 14 satellites per plane. But we're actually deploying about 10,960 telescopes amongst those 112 satellites in the visible IR wavelength. We're deploying about 154 radars in 3 different wavelengths, and then so some other odds and ends, including 52 hyperspectral telescopes. These are very large telescopes. They're 1.25 meter diameter aperture in space, some of the largest telescopes that have ever been deployed commercially. And the satellites are big. They have big power systems because they have to run continuously to capture all this data covering the whole Earth all the time. Now, typically a satellite today will image something. I'll take a snapshot of something and then continue on its orbit until its memory is full, take pictures, and then come over a gateway, a ground station, and then it downlinks to the ground station, and then from the ground station back to the processing center, the data is backhauled. So you might get you call up a satellite company and you say, well, give me an image of something, and they, 3 or 4 hours later, at best, maybe 3 days later, you get a picture or a snapshot of what it was you're looking for. Our system works a little differently. We have both the LEO satellites, which are constantly imaging or capturing the data over the whole Earth, which are linked continuously through laser comm to a higher orbit MEO system, 8 satellites that capture the data. The data is constantly streaming out of the LEO satellites off of the sensors, and then it's circulated back to our ground station and is streamed back continuously. So the time between when an image is captured by any one of the satellites or the video is captured by the satellites and the time that it arrives in the ground station is about 3 seconds, and that's for all the data that's collected throughout the constellation continuously. So that's something that makes this essentially a real-time system. Basically the magic thing that we're going to do here, there's 2 magic things. One is we're going to have the capability to take a new image of the entire Earth at as fine a resolution as ½ meter as fast as twice a second. It's an enormous amount of data. We have some special ways to make that happen. But imagine a video like Google Earth of the whole Earth happening sort of continuously in essentially real time.
I know NASA, a few years back, they were going to do what they called Mission to Planet Earth. And they put these satellite constellations together. And then they said, whoops, we're going to have to cut down the resolution because we don't have the processing power to process the amount of data that's coming down. And I understand you're going to be producing something like 27 petabytes of data. And that's a big number. In fact, you might explain what a petabyte is.
Yeah, so petabytes is 1,000 terabytes. It's
1,000 trillion, but 1,000
yeah, correct, yeah. So it's a lot of data. So the sensors actually will run continuously, and if we captured and used all the data in its raw form, it would be hundreds or thousands of petabytes. So we actually have processing on board the satellites to do some, down selection and some reduction of resolution in places where it makes sense. So for example, if you're looking at clouds with a visible sensor, there's no point in having ½ meter resolution of the back of a cloud. So we have systems that reduce resolution on board in order to make this, even remotely manageable. But that 27 petabytes a day that's coming down from our constellation is compressed. So uncompressed, it's even more. And that actually is the toughest part of this system. Every sensor we're putting in space has been put in space before, even if it was on a classified, considered classified mission. And so I don't want to trivialize the satellites, but the hard part is actually not the satellite. The hard part is ingesting this volume of data and doing something, useful with it, sort of in real time and processing it. That wasn't actually possible to do even 5 years ago. So there's a lot of new things that have happened in technology world that are now proven and useful that we're putting to work on the ground with this system.
Putting up a system like this is not an easy thing to do. I was involved with putting up a lot of Intelsat satellites and the regulatory aspects. So where do you stand on the regulatory aspects of getting permission to license and put these systems up?
Yeah. Well, so a lot of people who may be on this webinar don't understand how the licensing works, but it's actually not trivial to get a remote sensing license, especially one for a system of this scale. We are fully licensed now by NOAA and BFCC for our system to deploy. We're building and deploying it now as we speak. And then the key really is the NOAA license for us. As some people may or may not know, NOAA actually aggregates the input from about 15 or 18 different government agencies who all have the right to sort of comment and put input in on our licensing. So really what we've gone through is a very difficult process with the US government to assure the government that we're going to comply with not only the regulations in place, but future regulations that may come into place and privacy laws and so on. It's been a tough process, but we're now fully licensed.
The other question I think that comes up when you're talking about a 0.5 meter resolution system and millimeter precisions on some of the things that you're examining, of the question of privacy and surveillance and so on. Is there concerns of that regard, and what are you doing about those concerns?
Well, yeah, so there's a sort of a complex answer to this, but yes, privacy is extremely important to us, and of course, not only complying with the laws and so on that are around the world in various countries, but actually, behaving ethically and respecting privacy. Our system is much more about creating transparency in the world than it is, a privacy issue. So, for example, we have the resolution to say tell the difference between a person and an elephant, okay? But we can't tell who a person is. We're much more interested in how many cars are on the freeway than who's in a car, all right? Or for example, how many people are going into the hospital, and did they suddenly a lot more people go into the hospital? But we don't know who's going into the hospital, and we don't care. That's not the business. Our business isn't about providing raw data that other people may misuse as well. So most of our business, 99% of the business, is analyzing this data set and producing useful analytics or useful feedback to businesses or physical businesses and physical activities in real time that can change the outcome of something, in the near future.
Clearly, you really are a data analytics company. You're just using the world's most sophisticated tools to do it. So the real question is, what is this all going to do? How are you going to make the world better? How are you going to help us deal with pandemics, global pollution, climate change? What are the various things that this system can do to make the world better?
Well, there's a lot of things we can do and will do, and we're quite excited about that. So there's sort of two parts to Theia. One part is the business itself, and the other part is the foundation and the philanthropy that we've started. So I'll just talk generally about some of the things you highlighted. Our system, as I started to mention, has also hyperspectral capability on it, which allows us to understand things in the non-visible realms, so we can understand pollution in the air, to very precisely analyze what chemicals are coming out of a factory or whatever. And so we can actually measure all 54 essential climate variables from our constellation. and we're going to provide that data to climate researchers for no cost. It'll be, we think, a sort of order of magnitude revolution in the accuracy of climate models, and also understanding the source of problems in the climate. It's one thing to know that there's a lot of pollution somewhere. It's another thing to know where's the pollution coming from and exactly, what's causing it, right? And we'll be able to identify those things. Let's take an example like agriculture. Our system will be able to capture the hyperspectral and ground penetrating radar representation of the entire cultivated area of the world 3 times a week. We will process that into precision farm analytics literally for the entire cultivated area of the world, and distribute that or make it available through the foundation for no cost to farmers. There's other ways we're going to run the business, but speaking of things that might change the outcome of the future, well, there's 2 right there, climate and agriculture. But there's lots of other aspects to the business that make money that are, supporting the long-term future of this piece of infrastructure in space. And the way we really view it, Doc, as a piece of infrastructure in space, and not unlike a cell phone system, right? There's 2G, 4G, 2G, 3G, 4G, 5G. Well, there's going to be TSN1, TSN2, TSN3. But we'll continuously make available or create this living digital representation of the Earth at a pretty fine granularity with a lot of quality and detail that enables scientists and researchers, and as well as business people, to change the outcome of physical things happening on Earth for the better.
I'm working on a book right now on mass extinction, and the fact that one of the things that people are concerned about that might be a bigger problem than climate change in terms of effects are the acidity in the ocean building up. And basically, it's the algae in the ocean and plankton that produce over half of the world's oxygen. And so things like being able to monitor the acidity in the ocean, to me, might be one of the biggest things that this system can do, because we can't lose half of the world's supply of oxygen and the systems that are eating all of the greenhouse gases. So that's just one example of something I'm currently doing research on that I think that.
You're exactly right, Doc. And our system will measure ocean acidity, ocean salinity, ocean temperature to very accurately. I don't have all the numbers in my head sitting here, but again, actually you cited a few of the essential climate variables that we will be able to continuously measure on a highly granular and daily basis and provide that data to climate and environmental researchers.
And one of the things that people are worried about these days are the COVID-19 virus. And is there something that your system could do to monitor or identify a pandemic before it happens or as it's happening quickly?
We've done some analysis of that, and what you're talking about is the ability to understand patterns of life that might affect somebody else nearby, right? And then this is really what transparency is about. People are doing things in different countries or nearby you that affects you and affects your life, but you don't know about them because, in the case of the Wuhan virus, some particular government didn't want to tell anybody. But when our system is up, we will be able to rapidly determine that, say, normally 100 people go to the hospital, but suddenly 1,000 people went one day and 3,000 and so on. And again, we don't know who went, we just know that more people are going. We can't identify an individual person, and we don't want to, and we don't need to. We just know that something's going wrong. And, then we can sort of sound the alarm and say, hey, government or whoever needs to know, hey, there's something going wrong here. Let's, send help. Let's help them. Let's figure out what's wrong and do something about it before it becomes a pandemic, right? Imagine if we'd been able to tell the world in October of 2019 that there's a pandemic rising out of the Wuhan province. We don't know what it is, but something's going terribly wrong there. That could have made a big difference in the world, and that's what we mean by transparency. Again, there's no violation of privacy. We don't know who's going to the hospital, and that's not what matters. We just know a lot of people are going, and something needs to be done. And it's not just about warning us to avoid travel. It's also, hey, let's go help these people. There's something terrible going wrong. We've got to help them.
Well, I teach a course at the University of Cape Town, and the students there, they've been very worried about water. I was there close to 0 day in terms of the water supply for Cape Town shutting down. So I know there are countries all over the world who are really looking for capabilities about water, about the spread of pandemics. A couple of my students were working just on that issue of spread of pandemics and how do you chart that and so on. So this is really interesting stuff. So let's talk about customers, though. Foundation is great, and the good things are great, but how do you make money? Do you have some customers, and what are they interested in?
Yeah, well, we've been really fortunate to be able to sign up some early customers and early subscribers that are quite significant, and that's based in no small part on proving what we can do from the aircraft, and then showing how it scales globally with the TSN. I'll give you a couple examples. Today there's about $3.5 trillion worth of premiums written every year in physical insurance, fire insurance, flood insurance, things like that. Well, there's a huge information asymmetry problem in that insurance business, which is sort of nobody has the before and after picture of what happened, right? Well, when the TSN is up, we'll have the before, during, and after picture of every fire, every flood, every car crash, every plane that disappears. And we can help not only reduce those risks or even help clients eliminate risk, but then when it comes to adjudicating the claim, the insurance company will have sort of clear proof of what happened or didn't happen and can pay out claims much more rapidly than they do today. So imagine that a hailstorm comes through and wrecks a cornfield. Well, we will have the before and after of that. The farmer can be paid out literally within days without even having to send an adjuster. That's one example. Another example is infrastructure. So our system will be able to measure 15 different anomalies of pipelines 3 or 4 times per day. So we'll see every leak in every pipeline around the world, and we'll process all the pipelines for these 15 anomalies we know how to do, regardless of whether any particular pipeline operator is a customer or not. But it gives you an idea of how the business can scale. Agriculture will be able to do precision farm analytics literally for every farmer in the world as if they had their own personal drone or their own personal agronomist. Now, as I said before, we're not going to make money on the farmers. We give that to the farmers for free, but we can make money on agricultural credit products, insurance products, chemical sales, and things like that. Basically, we're going to have a digital recording that's live, or digital record of sort of everything happening on the earth. And you can imagine a platform where we don't sell that data, but you bring your ideas and applications to our platform, and you can sort of understand anything about the physical world you want with APIs and algorithms that you bring to us. So we know how to do some algorithms that we think are going to be money makers, but ultimately the system's a platform for lots and lots of both government and commercial interests to come bring their algorithms to and create this measure, model, modify feedback loop that helps the business or the activity become more efficient.
So will you have government as well as private entities both as customers?
Yes, yes we do, and we have signed up several governments to our system already. And in those cases, we're, again, doing things sort of on a nation state scale that can't be done any other way. So there's things like border security, which are sometimes controversial, but the big things that are easy, like agriculture. So if we can change the agricultural output of a country by even 10%, well, that's a whole point or two of GDP in some cases, right? Or make it more efficient by 10%. That's almost impossible to do if you're trying to, say, sell drones or something like that. But it's actually quite possible to do with a system like ours, where we can capture and process the entire cultivated area of a country in less than a week. And that's kind of gives you an idea of the scale of things that we can do to help governments.
This on the 25th of September, I'm involved with a webinar on the whole issue of orbital space debris and new systems to try to do active debris removal and so on. As I mentioned earlier, you have a much smaller number of satellites than these thousands and thousands of large constellations that Amazon and SpaceX and other people are thinking about. But what are you thinking about in terms of removing your satellites and basically being a good citizen in terms of not leaving space debris in orbit?
Yeah, great question. Well, as I mentioned earlier, we intend for the TSN to be a piece of infrastructure in space essentially going forward forever. Certainly we'll improve it and expand it. But what that means is when one of our satellites is at end of life, we got to get it out of the orbit, not just because we want to be a good space citizen, but we got to put a new one in its place. So we have, our satellites are quite large. They, as I said, they have big power systems. They have big, large sensors with big apertures in order to capture this decision grade quality data we need and do it continuously, right? So it's not like we take a few snapshots and then wait a while. We're continuously operating these sensors all the time. So these big satellites have got to get out of the way when they're at the end of life. That's a lifetime of about 10 to 12 years. And we have sufficient fuel on board to deorbit them within less than 3 days. So literally, when a decision is made at end of life, then we press the button and it deorbits and burns up in the atmosphere, falls into the ocean, and then we can replace it with a new satellite in the same orbital position.
Well, there used to be the so-called 25-year rule for removing stuff, but when you get into a situation where these constellations have lifetimes of 7 years, 10 years, 12 years, the mathematics don't work because you can't put new satellites in until you get rid of the old ones. So clearly we're in a new ballgame. Well, we've taken up sort of the first 30 minutes, and I think that Norman might have questions in from the audience, so I think I'll toss it back to him.
No, I appreciate it. Thanks very much. I was listening, but I wasn't there. Well, we had one of the audience members who asked a facetious question: is space real? So you guys can probably say that space is in fact real.
Well, here's my comment. I'm sorry, go ahead, Doc, if you want to take that question. I'll take it. I think the real promise of space and all this new frontier space stuff is not about space at all. It's about Earth, right? One of the big things that has to change, and for us to improve mankind, improve socioeconomic outputs, is we need to be able to sort of do for the offline world what has already been done in the online world, right? Today, the online world is all digital. It's hyper efficient. Say what you want about it, but it's very efficient. The offline world, the real world where we all live, is not efficient at all. And one of the reasons is because there's no way to apply digital tools and processing to some of the problems in the real world that we have. And that starts with having a digital representation of it that's essentially real time or evolving, right? Not just a snapshot of this thing or that thing that is slow to be available, but something that is continuous in real time. So this is really the watershed thing that the TSN is doing, is building the foundation for using digital tools to apply to problems in the quote analog real world that really can't be solved any other way. So we think, again, back to your question, space isn't about space at all. It's about Earth.
Yeah. No, I think that.
I'll just add a couple of words if I can. I've written about 50 books, but two of the last ones I've written, one is The New Gold Rush, The Riches of Space Beckon, and the other one is Space 2.0. And both of those books basically project that we will have at least $1 trillion industry based on space activities, and all that money is actually here on Earth. And Merrill Lynch has done a study, and they basically projected that it'll become a $3 trillion industry. So I don't know what people consider real, but a $3 trillion annual income from space-related activities is probably real to a whole lot of people who will have jobs.
So I would say the opportunity is even bigger than that, Doc. We view the world in a binary way, there's a bunch of online stuff and there's a bunch of offline stuff, right? And the offline global GDP is something like 65, 75 trillion a year. And that's something that hasn't really been touched very much by digital technology. And that's something we're going to affect. Our system will be able to make demonstrable difference in the outcome of, ultimately 65, 75 trillion of global GDP. We don't know of anything else. I mean, forget about whether you like the TSN or not, just being able to remote sense and cover, build a digital model of the entire Earth is something that addresses a bigger market than anything else on Earth. It's a gigantic market. It's going to be bigger than the internet, bigger than the online world. It's going to be huge.
One of the things that's happened is that actually Silicon Valley has discovered space. And we see Amazon, and we see Facebook now putting up space systems, planning space systems, and so on, and that the whole new economics and the whole building of satellites is actually coming with new models, and that's what I mean by Space 2.0. It really is a whole entrepreneurial spirit that's looking at space in new ways.
Yeah, it's really interesting. This has been a fantastic conversation. One of the questions, I think, well, obviously all the questions are going to you, Erlend, but one of the questions took off from your observation in terms of pipeline anomalies, and was trying to figure out what other applications you see for infrastructure, since everybody here.
Yeah, so our system will be able to of major infrastructure in the world, so circa once per day, maybe a few times per day for a number of anomalies. So we have some algorithms today that look at the movement of bridges using INSAR radar techniques, and we'll be able to do that essentially for every bridge in the world. Okay, every building, foundation, pollution. There's just a plethora of things that affect infrastructure every day, whether it's its operation or its safety, or the ability of a particular piece of infrastructure to support more loads or more traffic, whatever it is. We'll be able to provide precision, quantifiable, measurable metrics about those kind of pieces of infrastructure, how they're functioning, and what the problems are, potential problems are with them. So infrastructure is a very big business to us. We think it's one of the most important, probably the top 3 or 4 business for us going forward. And we're a piece of infrastructure too. You can think of the TSN as a piece of infrastructure that analyzes and understands all the rest of the infrastructure.
No, it's fantastic. I mean, I really, obviously we work pretty closely with you guys and we like what you do. But, I've always seen infrastructure as almost a data-free zone. And all of a sudden, Theia is going to provide a huge amount of data about the condition, quality, demand for infrastructure all over the world. I mean, I suppose, in terms of thermal sensing, you're also going to be able to show where we have problems with our transmission system, where we have most leakage, all of those issues that nobody knows anything about right now. They're absolutely critical to how we operate, how we spend, risk, et cetera. So.
Well, thanks. Yeah, I mean, things like soil quality and floods and what happens to the foundation of a rail line when there's a flood. We'll be able to measure those kind of things for operators and governments around the world on a highly granular, highly accurate basis. And that, it forms the basis for a great leap forward in socioeconomic capabilities and logistical support, but it's also a pretty gosh darn good business too.
Yeah, when the first time I talked to you guys, it was fantastic. The vision is just spectacular. Well, let me give you guys a final word. We don't have any more questions. We had those 2 questions, but I just want to give you guys a final word. It's 5:40. We were actually only going to go to 5:30, and then we decided to expand it a little bit. So a final word from you guys would be great. But did you guys cover the issue of when you guys are going to be up in space?
No, we've started building our prototype hardware. Our launch is basically production launch will start in early 2024 and go through late 2025, early 2026. So the system will be sort of fully operational on the current schedule, sort of, let's say, early 2026, mid 2026.
And
That's
you also have to build something the equivalent of a Googleplex to process your data.
Well, yeah, as I mentioned earlier, the processing, ingesting this much data and doing something useful with it is actually the toughest part of the system. And solving that problem, which we have now largely solved with some new techniques and new ways of processing data, that actually wasn't possible, and even 5 years ago wasn't possible. So the improvement in GPU and FPGA speeds and memory speeds has enabled us to do what we're going to do in a pipeline fashion on the ground.
That's amazing. So Joe, 50 years ago, when you first got involved in this business, or however long ago it was, did you imagine something like this would exist by now?
Well, it's always amazing how quickly things went. I started out with the early bird satellite that had something like 64 circuits on it. And when I left, there were about 15,000, and now we're talking about something like hundreds of TV channels and hundreds of thousands of TV channels. So it's gone always exponential in every regard. And that exponential that we saw in telecommunications, we're now seeing remote sensing. So it'll just be amazing what Theia is going to be able to accomplish in the next 5 to 6 years.
That's fantastic. I think that's a good place to stop. Thank you very much, you guys. That was really phenomenal, and congratulations, the vision and the execution. It's really wonderful, and I really enjoyed listening to you guys. I cut myself off, but I was listening the whole time, so it was great. Thank you so much. Really appreciate it.
Good to see you, Doc. We'll talk to you soon.
Good to see you guys too as well. Thanks so much. Bye-bye.
Many things are commonplace today that were unimaginable only a few years ago. For example, it took only 20 years for nearly everything written and transacted to become digital and made available across the world instantly. This is the online world, a world where the internet has become an essential piece of infrastructure and everything is digital and hyper-efficient. But ironically, some of the most fundamental problems of daily life still remain unanswered by our digital online world. Our offline world, our physical world, remains mostly analog, massively inefficient, and poorly understood. But what if we could continuously digitize every physical object and activity on Earth? And what if we could digitize not just what occurs in space and time, like a video, but also precisely understand the chemical composition of nearly everything as well? And what if we could analyze all of this digital data in real time to answer questions and solve problems as they happen, as daily life unfolds in the real world? Soon, we will. Theia is building the Theia Satellite Network, a permanent infrastructure in space which will make the digitalization of the Earth a reality. The TSN is a constellation of satellites that will digitally image the entire Earth at half-meter resolution, twice per second, through day and night, clouds and storms. The TSN will also continuously capture 752 bands of hyperspectral and ground-penetrating radar data, enabling an understanding of the composition of nearly everything on Earth as well. The entire surface of the Earth continuously imaged and digitally characterized. Every object and activity understood. Every tree on Earth, digital. Every truck, digital. Every whale, digital. Every building, every source of pollution, every ship, every farm, all digital, all understood in real time. This is the digitalization of the physical world. Imagine every farmer on Earth receiving a quality weekly farm prescription, meter by meter, showing precisely how to increase yield, reduce costs, and bring their harvest to market. Imagine wildlife conservation agents preventing poaching threats, saving not just a few elephants, but saving the life of every elephant by stopping poachers before they even get close. Imagine the movement of people, traffic, and goods made more efficient as transportation authorities and logistics companies resolve problems on every mode of transportation in every country in real time. Imagine authorities and infrastructure operators will be informed of the weak points of bridges, the subsidence of foundations, and the leaks of pipelines to pinpoint critical repairs before failures occur. These are only a few of the real-world solutions and applications that will rise on Theia's platform. With the TSN, Theia introduces a new reality at a simultaneous scale and granularity that is unprecedented. The Theia Satellite Network, a technological reformation, finally benefiting all life on Earth.